everyone, and thank you, Jen, for introduction. I'm so glad to be with you here today. And well, as you can guess, I'm probably going to talk today about Nitro and some reasons that why you would need it if you are not already using it. First, for introducing myself, I'm Pooya Parsa or PI0 in GitHub and Twitter. I'm a core team member of Nuxt. I'm creator of OnJS and a project called Nitro. You can follow me on social media if you want to get in contact or if you have any questions in the future. Okay, let's get started. Nitro. Nitro is a server toolkit or a server tool that you probably need if you have not heard about it. But during this presentation, we will learn why and why you would need it for your front-end project. First question is that usually people ask that, okay, if I'm a front-end developer, if I'm focused on making beautiful front-end applications, working on frameworks like Vue or React, why I would need to be a back-end developer, why I need a server. Well, let's see the answer. Well, the reason behind it, we have to come back to a little bit back. The web development and the technologies that used to make websites and power websites and run them have been evolved. Probably almost the age I born, everything was so simple. It was just a simple HTML web page with a markup and some small styles on top of it to make it more beautiful. And this is how the web was born, right? The pages was eventually more and more dynamic. They was adding more functionalities. Many of those functionalities was basically just static plus some things that seems like dynamic, like the plugs that people used to make with some effects on the page. And it required a new language called JavaScript. And this was the start of evolving them. Over the time, more patterns created to make more dynamic server content generation on the server. Not every website was static anymore. And one of the patterns that was so popular over the years was model view controller, which was essentially splitting the business logic from the view logic of the applications. It was still on the server side, and it was returning some static content plus some dynamic scripts to make it more interactive on the client side. Over the time, to reduce the complexity and to further split the business logic from the front-end side, this is probably the time that front-end application became front-end development became a thing. It was single-page applications, which essentially meant that server would be remaining just an API, doing the business logic, doing the server queries and backend stuff, and the front-end side that is JavaScript code that constructs the HTML source code for us and adds styles and everything. So it was almost the time that we started to see things as separated. But it was not that easy. Very soon, people figure out that SPA and single-page applications have some limitations. If we want to load everything on the client side, if we want to render everything on the client side, we have some disadvantages. For example, with search indexing. We also don't have fast performances because small devices and slow devices have to render everything on the client side. So new technologies came called server-side rendering, which was essentially doing whatever happening in the browser also on the servers. And this is the time that frontend, the modern frontend that evolved from the browsers, became its way through the backend, and server-side rendering started. More patterns added. For example, this response from the server could not be streamed. And recently, we have seen so many new innovations in this area. Server components and server actions, for example. Literally now you can use a server action to make a database query or just create a server component that has backend and stuff inside it. So, well, honestly, there is no clear boundary anymore between front-end and backend. Everything is mixed. And, well, this was the thing I was exactly thinking about. It's front-end code, but really, whatever we are making, what the frameworks that we are using for making most of the modern web applications, they are becoming a full stack framework because of the needs that we need. First, we started as simplest things, single page applications for front end to separate it from the backend, but we slowly started to have our way back to the server rendering, and now we have all insane. When you are usually developing front-end project using the recent tools, usually there are some common needs. First of all, if we are going to interact with the backend, I think it's something that we can all relate, that we need a clear API response. We don't need backend logic inside it. We don't need complex and nested objects from the backend. If they are complex, they are probably also big, and it means that the pages are slower to load because we are loading unnecessary stuff, and we have to filter and clean it up on the client side, which is something that is sometimes a problem if there is no connection. Another thing that we always need if we have a separate frontend from the backend is that we now expect fast API response. And fast usually means that we need to cache it. So if a lot of people are watching and requesting wanting from the server, we do not compute it every time. We cache it and we send a fast response. And because of the front-end technologies became more complicated, we now have SSR, we need authentication, we need session support, we need headers for things like CRS headers. We need redirections, we need a lot of stuff that it means that front-end needs full access to the server, whether it's called backend or front-end or whatever. We need full access to it. We need full power as a front-end developer. And this is where the backend for front-ends come. And Nitro, you will see that is providing some of the functionalities that we need to fulfill these requirements for building a modern application that requires some backend stuff. Okay, first I want to have an overview about Nitro Toolkit. Basically, what is Nitro? Like, we are always referring to Nitro. What is Nitro? Is it server? Is it builder? What is it? The first thing that when you getting started with Nitro, it's similar to frameworks like Nuxt. You have a fast development server with hot module replacement. So you can start creating some API routes or some even renderers, and you can save them and instantly see the result of them. So the first thing that it provides is a development server. The other thing that Nitro provides is a production bundler, which is today powered by Rollup, and in the future it will also be supported by Wheat. And once you write your code, whether it's just a backend application or it's a mixed full stack application, it can bundle it for you and make it ready for production using all the presets and configurations similar to other meta frameworks like Nuxt. Nitro also provides a really elegant dev experience powered by TypeScript. Everything that you develop using Nitro is already typed. Even some of them are intelligently auto-typed on the runtime thanks to the works of Daniel. So, for example, if you write an API route, it's already handled and typed when you want to fetch something. It's all magic. And I highly recommend you to watch 2 other talks from yesterday to see more of it in action. One of the other things that we tried hard to achieve, and despite other frameworks that are usually made for one deployment provider, for example, like one of the providers, every API that is in Nitro is vendor-free. It means that the code that you write is not targeting one deployment target. You can change your decision anytime. You can deploy to your own company server. You can deploy to Edge. You can deploy to anywhere that you like. Nitro was born when the Cloudflare work has started, and the idea behind it was to make a truly universal server that is ready for Edge, but also open to deploy anywhere you want. So essentially, everything that you make with Nitro or what application you have that is powered by Nitro, it can be universally deployed on Edge or your server, or any of the 25 deployment providers that Nitro understands them. It knows how to configure and build a bundle for them, and then it can automatically deploy it for you to them. Nitro provides a lot of other features. For example, API routes. You can easily use the file system API similar to Nuxt that is used for pages to define your API routes. You can use the layer of Nitro that is made for server-side rendering, which is internally used by other frameworks, to create a meta framework that has server-side rendering functionalities. You can use the powerful caching API of Nitro that is completely standalone to cache your API responses with almost no configuration. Basically, you can start application and cache whatever you want You don't need to reinvent the wheel. Nitro also has a powerful error handling system, whether it's in development cycle or in production. It can handle errors and also has hooks, so you can report them to whatever you like. Nitro has full access handling for, yes, first requirement for a front-end application is responding static assets like JavaScript files and CSS files, but also server assets for bundling assets that you need on the server side. For example, the fonts that you need to render something. Nitro is the only framework that provides a truly universal WebSockets API. It means that whatever WebSocket connection handler you write in Nitro, it can be used across deployment presets. And that's one of the things that we are very proud of, that we are always open. Whatever we make, it's for everyone. Nitro provides the key value storage, which is really useful for creating simple applications, for caching, for storing things like configuration inside this key value storage. And it's also universal, so you can change the deployment, the implementation. So you can say Nitro, hey, please write my key values to a file system, or write a key value, or Redis, or database, or wherever you like. So key value storage is also universal. You have a unified and simple API for storing simple data on the server, and then you can decide and choose where you want it to be stored. Nitro also has an experimental database API. It's like a database connector. So you can quickly get started, even you don't need the configuration, because when you start a Nitro application, you have a SQLite database configured. You can use a simple utility to make queries and store data in the database as an alternative. So you can choose between a key value storage if you want that, or we can use more complex relational databases. All are configured out of the box for you. And this is an overview of Nitro applications. So in conclusion, Nitro is a combination of server bundler, it can development server, and built-in features that can help you to create your full stack application. Oh, the last thing, tasks API. Sometimes requests are not coming from the client or an API call. Sometimes you want to run something in the background. You want to make a database migration. You want to every now and then fetch the data from a CMS to update the content. This is where the Nitro Tasks API comes. You can schedule something in the background. Say, okay, every day after 6 hours, I don't need to redeploy something. Just after 6 hours every day, fetch new content from CMS for me and rebuild the pages or prepare the data so the users can get the new data. If you want to use Nitro today, if you are using Vue or you want to use Vue for your front-end application, you can use Nuxt. If you want to use Angular, you can use Analog.js. And Analog.js is a framework that is, and Nuxt are the frameworks are built on top of Nitro. If you want to use Solid, you can use Solid Start, which under the hood is powered by Nitro, and you can use many of the features of Nitro. And if you want to use Nitro for anything else, like if you want to just create a package application, or if you want to combine Nitro with your own rendering logic for any other framework, you can directly use Nitro. So it's similar to it. You can directly use Nitro or use it within another framework. And some exciting stuff are coming soon. Something called Nitro Kit is going to make it much, much easier for creating any meta framework and SSR integration. One of the things that you probably as a front-end developer would like to know about Nitro or probably use it is the route rules. Route rules are available for Nitro, Nuxt, or any other Nitro-powered application, and are a really powerful API. Despite that it seems a simple configuration, they allow to have so many flexibilities over your full-stack application by just using some rules and configurations. We can use the rules for an easy way of doing the caching your responses. So you don't need to write your own complex caching logic. Nitro internally integrates with the storage layer, key value storage layer, and its own built-in caching layer. And when you just define something like the blog rules, like every route in the blog of my website, I want it to be for 1 minute cached. And you can just enable a stale variability strategy. Nitro automatically, every time the first time request comes, it caches for the next ones. You don't need to configure anything else. It's so common that you want to specify some common headers like caching controls or CORS headers. You can also configure them using route rules. You can define the redirection rules. And something interesting about it is that it's not just in the runtime of Nitro. If you deploy, and if you imagine that you define that I want one page to be redirected to another page. If you use Nuxt, for example, and you build a full-stack application, these rules can also be universal. It means that not only on the server side redirects happens, Nuxt understands this and can do the same redirects on the client side. Also, it can be understood by the deployment providers, for example, Netlify. We don't need to hit the responses here to find that we need a redirect. Nitro just automatically understands what deployment provider they need, and it can output these route rules to the configured route rules for that deployment provider. And also, one of the most powerful APIs of these route rules is proxy. It's very common that sometimes you have several backends for your front-end application, and since we have a full server, we have full control over it. It's on the same URL. We can simply use proxy system of Nitro to proxy some of the API paths to an external server. I would recommend you to watch Alex Fischer's YouTube channel. He has some interesting videos explaining more about the proxy, especially. One of the other things that Nitro provides, and it's essentially the basis for creating a backend application, are API routes. Usually when you are developing a front-end applications, it's not everything is just HTML response. Sometimes you need a JSON response. Sometimes you need to run some backend logic to make a database query. Sometimes you need to fetch something on the backend, clean it up, and then respond it back. Sometimes you need to cache something. Without a backend layer, without API routes in the backend layer, usually what happens is that we do the same thing, but on the client side. That's something that is not performant because we are doing it on every user's client. Using a Nitro API route, we can do this on the server side, and we can do simple things like this. And this is basically the means for creating a backend for frontend. Essentially, a backend that is optimized for the frontend. And the frontend developers are usually in charge of optimizing it for themselves. One of the other powerful parts that we made through Nitro is OFetch. OFetch is a library that we made as a wrapper for fetch instead of patching it, instead of creating more complex fetching libraries. It's the bare minimum library that adds a lot of the experience improvements to the native fetch. And fetch is an API is a way to get other API responses. The first thing that it provides is that you can safely parse something. You don't need to worry that if the response is JSON or text. It can serialize any body type for you, like a buffer or a JSON. It automatically understands it and serializes it for you. It handles the API errors. Usually when you use a simple fetch, you have to manually check the errors yourself. You can catch them and use a beautiful API to show it. So, and more features like interceptors, retries, times out, and query parameter serializing. And well, it was really my reaction when I made this library and available product because it was making life much easier without adding complexity. And today, thanks to the other contributions like Daniel's work on the fetch type fetch, in Nitro, you have even more dev experience improvements on fetch. For example, the users that is fetched in a Nitro Nuxt application is typed, and this type is auto-inferred from the API route that you are defining. I hope this presentation was helpful. If you have any questions or want to involve more on Nitro development, feel free to reach out. You can use the community section or directly message me. Thank you so much.
All right, we do have a few questions for you. Let's take a look. First one, If I use Nitro, does it handle all of my server tasks uh, and I have to control it from the front end?
Yes, I mean, it depends. In most of the small and mid-sized projects, you can write most of the server logic and tasks and everything in the Nitro, and just in the front end, you can fetch it. This fetch is also integrated universally, so in the server-side rendering or console rendering, you can fetch it. If the project size or the team size grows, usually there are more backends. We can use proxy system of integrating with it. So yes, you can use it to handle everything that you need, I think.
Cool. Thank you. All right. Up next, is there any guidance or best practices for unit testing Nitro apps?
Well, the answer is no, but something exciting that I promise that there is something that you would be really excited for. Essentially, something that we are pushing for, and it's not possible today, is that unit testing something, unit testing a backend application means that we have to limit everything. We have to emulate the database. We have to have some considerations about data deployment provider, like how it works. And usually we can even test something in development cycle, and in production is different. So the idea that is coming to the core of Nitro is that we have a universal and runtime capable testing framework. Essentially, that something that is already deployed, it can have run test as health check test against real deployment provider. So no, there are not best practices yet. There is Nuxt test utils that provides all of the best practices for Nuxt unit testing for API routes, and the runtime testing is coming.
Thank you. All right. Best handling API approach, front end or back end?
That's a tricky question and also unclear. I think it depends on the needs. Like if there is a dedicated backend team, there are in many big companies there are. But something I would say is that always the front-end developer would benefit from a BFF layer. So even we have a front-end backend, dedicated backend or not, a BFF layer that is powering the front end can help to optimize things like responses or types and caching.
All right. And last question. What significant advantages does SSR offer in web development? Oh, I feel like that's a big question.
Yeah, I mean, it's a classic question, right? Like we had a CSR and we needed some needs that we added a server-side rendering. Well, I think two main answers are first search engines that they can quickly fetch the responses without running it. I think also AIs are the new guys; they can also like it. But the other thing is the user performances. So whenever someone loads a page, they don't need to run everything on their device, which I would say it's less relevant because latency is much more relevant today. And other than that, most of the devices are more powerful. So I think SSR still is relevant, adds to the complexity a little bit, but definitely worth it because not everything can run on the client, and there are more patterns like client server components that exist because there was some needs on it. For example, we want to couple a server component with some database logic. So I think SSR itself, the paradigm is changing. There are new requirements and there are new reasons that we need SSR.
Perfect. Thank you. And that's all of the questions we have for you today, Pooya. Thank you so much for joining us.
No, thank you too, and have a nice day.